Hey, what's up, guys? So this week we'll be covering two lessons, 3.4 and 3.5. This one's just about 3.4, and we're continuing our efforts to graph quadratic equations, quadratic functions. So before we get too much into the graphing portion, there's just one idea, one concept that I wanted to introduce um, before we get into the graphing, and that is the idea of even and odd functions. So an even function is a function that can be um, reflected over the y-axis and remain unchanged. So right here, if we were to take this example of x equals y squared, if we were to flip both sides, so either this side over here or this side over here, if we were to reflect it across the y-axis, you'll see that it will remain unchanged. So basically it's symmetrical. That's all we're saying. So an even function is a function that is symmetrical, but only that if it's symmetrical about the y-axis. So for example, if we had a quadratic function that was over here, the thing is, if you were to flip this function across the y-axis, then your function would be over here, which is not the same. And so this would not be considered an even function. So, but this right here, the parent function y equals x squared, the parent function of the quadratic, is an even function. And then there's the idea of an odd function. An odd function is when a function remains the same after you rotate it 180 degrees about the origin. So this is the polynomial function y equals x cubed. This is the origin right here. And if you were to rotate this about the origin 180 degrees, you can see that the graph remains unchanged. It would be the same. And then again, if you were to rotate it this way 180 degrees, again, it would still remain unchanged. So this is an odd function. So those are the differences. So basically an even function is a function that is symmetrical about the y, and then an odd function is a function that can be rotated 180 degrees about the origin and still remain the same. So that's the idea of an even and odd function. So go ahead, take a second and go and write in your own words what an even and an odd function is. So let's get into what the lesson is actually about, which is about graphing functions again. So far we have learned how to graph the parent function of the quadratic. So there's the parent function, and that was y is equal to x squared. And then we had stretches and shrinks. Stretches and shrinks, which was y is equal to ax squared. So the value of a either stretched or shrinked it, depending on if the a was greater or less than 1. And then there was shifts. That was y is equal to a squared plus c, and this shifted up or down depending on the value of c. And then we learned how to graph in standard form. So standard form was a quadratic that looked like y is equal to a squared plus bx plus c. And now today we're learning how to graph in this form right here, which is vertex form. So it's called vertex form because it's actually really easy to identify the vertex. As you might recall from last time, finding the vertex in standard form required you to use x is equal to negative b over 2a, and this told you the axis of symmetry, and then you had to use that to plug into your function to find the y value. So the vertex is a lot easier to find. It's a lot easier to identify the vertex when in vertex form. Hence the name vertex form, right? So And you might recall that this looks similar to y is equal to a times the absolute value of x minus h. And it is very similar and almost the same. The only difference is that instead of absolute value signs, you have something being squared in parentheses. So that's the only difference really, but you still do the same thing. So if you have the absolute value, if you have, sorry, not the absolute value, if you have the function a times x minus h squared, if h is greater than 0, so let's say h is a number like 2, then you have a times x minus 2 squared. So you keep the sign the same, but h itself is positive. If you have something like this, then you move to the right h units. On the other hand, if you have a times x minus h squared, but if h is less than 0, let's say for example a times x minus negative 2 squared, well that's the same thing as a times x plus, because you have two negatives right there, so it's plus 2 squared. So if you have something like that, then this is going to move to the left h units. So in order to avoid confusion, it's really hard for students to get confused about which way you move whenever you have a positive or a negative h. So pretty much you just have to read it backwards. So just know, it's important that you know this. So if y is equal to a times x minus h squared, if this is negative right here, if this is minus, then you shift to the right. Shift right. If y is equal to a times x plus h, shift left. So so you do it the opposite. So if this says negative h, you're actually going to go in the positive direction. If this says plus h, you're actually going to go in the negative direction. So it's the same thing like the absolute value functions. So let's go ahead and do an example and see if we can apply what we've learned here. So it says to graph g of x and compare it to f of x. So we know what the graph of f of x looks like. So let's go ahead and graph the parent function. I'm going to graph first my x and my y axis, like that. And so remember how we graphed, we would plot in 3.1, we learned how to graph the parent function. So when x was 0, the parent function was also 0. When x was 1, it was also 1. When x was 2, it was 4. When x was 3, it was 9. So if we started here, it looked like this. So this was the parent function of the quadratic function. Okay, so now we want to draw g of x. And g of x right here is 1/2 times x minus 4 squared. Just note that when you have a value outside right here, it's the same thing as whenever we did y is equal to ax squared. So this was either a stretch or a shrink. So in this case, a is equal to 1/2. So we're going to have a stretch. So we're going to stretch the parent function by, or we're going to shrink the parent function by 1/2. Okay. The only thing that's different here, though, is that we are shifting our function in a different direction, right? So our origin is no longer going to be at the center. Okay? So, first thing that you want to do when graphing functions with a shift, with a horizontal shift, is to plot the vertex. Okay. So again, we talked about up here, if it's a minus h, you move to the right. So in this case, we have a minus 4. So we're going to move to the right 4 units. So we take the parent function right here, and we're going to shift it 1, 2, 3, 4. So our vertex will be right here. Now, again, usually we'd do the same thing where we'd go up 1 over 1, like that, and then up 4 and over 2, so we'd be right there, but we're shrinking the graph as well by 1/2. Okay, so now we have to figure out what the outputs are going to be for g of x. So, since our x's are no longer in the same spot, let's go ahead and try and graph it though. So we know, first of all, that when x is 4, y is 0. So when x is 4, we're graphing g of x, y is 0. G of x is 0. Now let's try putting in the value of 3 into the graph, or into the function. So let's plug in g of 3. Okay, so that's going to equal 1 over 2 times by 3 minus 4 squared. So that's equal to 1 over 2 times by negative 1 squared. So that's going to be 1 over 2 times by 1 squared. That's ultimately just going to be 0.5. So 0.5 or 1/2. So whenever x is 3, y is 1/2. So you see here that we're no longer at 1, at 1/2. Okay. Now we can continue. Let's try when x is 2. So this is when x is 2. What will g of x be? So we can do g of 2, which is equal to 1 over 2 times by 2 minus 4 squared. So g of 2 is equal to 1 over 2 times by negative 2 squared. So that's g of 2 is equal to 1 over 2 times by 4, and that's equal to 2. So when x is 2, y is 2. Okay, so you should notice that for the output for f of x, it was 0, 1, and 4. You can see that these outputs are divided by 2 or multiplied by 1/2. Okay? So then our graph should look like this. So that is the graph of g of x. Also, I forgot to mention that we do know that the graph faces upward because the a value is positive, and then that's whenever we took into the account the shrink or the stretch. Okay, let's keep going. So right here we have f of x is equal to a times x minus h squared plus k. So the only difference here is that we have a k value. So right here, this is the same thing as y is equal to ax squared plus c. So the c and the k they do the exact same thing. So if you have a k, you're either going to go up or down. And again, this should look familiar to y is equal to a times the absolute value of x minus h plus k. So this is where you have both a horizontal shift and a vertical shift. So you have both. Exact same thing. So in this case, you will have a horizontal shift and a vertical shift. So if k is positive, you go up. If k is negative, you go down. So if k is positive, you go up. If k is negative, you go down. So in this example, you can see that we have a horizontal shift, a vertical shift, and we have an A value. Okay, so if we follow the process that we lined up here, so first thing that we want to do is to plot the vertex. So first of all, let's make sure that we have our X and our Y axis. So there's our Y, and there's the X. So starting from the origin, we have plus 2. If it's plus, you move to the left. So here we're going to go 1, 2, so to there. And then we have plus 3 on the outside, so that means it's plus k, so we go up. So 1, 2, 3, so right there. So that's where the vertex will be, no longer at the origin. Again, we're comparing this to the parent function. So now we have to consider if the graph goes up or down, if it opens up or down. So here the value of A is negative, so that means there will be a reflection, so it will be open downward. And then we also have a value of 2 right there, which means we're going to stretch the graph by 2. Okay, so we know that if we want to graph this, we have x and then g of x. So when we want to first plot the vertex, so the vertex was -2, +3, so that's the vertex right there. Because right here, -2, +3, that's where we shifted the vertex. Okay, so now let's try and find out what the value of the graph is. Let's say when x is -1, so right here. So when x is -1, let's plug that into our function. So g of -1 is equal to -2 times by -1 plus 2 squared plus 3. So it's equal to -2, and then that's going to be +1 squared plus 3. So that's going to be equal to -2 plus 3, and that's going to be equal to +1. So that's going to be, so when x is -1, y will be 1. And remember, it's a symmetrical graph, so then it'll be right there. The other half will be right there. So how about when x is 0? So let's plug 0 into the function. So g of 0, which means you'll have -2 times by 0 plus 2 squared plus 3. So that's going to equal -2 times by 2 squared plus 3. And that's going to be -2 times by 4 plus 3. So that's going to be -16 plus 3. So that should be -13. So that's going to be way down there. And so we don't really see where it's going, but we do know a little bit about what's going on here with these points right here. So we know that we're going to go that way, like that. And there you go, that's your graph. So again, the vertex, basically, whenever you're in vertex form, depends on this right here and this right here. So this is your x and this is your y. And that's why it's called vertex form, because it's easy to identify the vertex. So let's go down to some of these exercises. So it wants us to find the vertex and the axis of symmetry of the graph. Okay, so for this function right here, we don't have a k value, right? So that means we're not going to shift the graph up or down. There's no vertical shift. but we do have a minus 2 inside the parentheses, so this is going to be a horizontal shift, and because it's minus 2, we're going to move to the right. So that means you move to the right 2 units, so if you start at 0, 0, and this is an x and y value, you're shifting the graph to the right 2 units, so you're shifting the x 2 units and you're not changing the y, so your vertex will be 2, 0. That's your vertex. And then it wants to know the axis of symmetry. Remember how we talked about last time that the axis of symmetry is the x value of your vertex. So x equals 2 is the axis of symmetry. Okay, so let's look at number 6 then. So for number 6, we don't have a plus or minus k value, so we're not shifting up or down, so that means the y value will be 0. So the y value will be 0. Here we have a plus 8, which means we read it backwards, so we go in the negative direction 8 units. So negative 8 is our negative 8, 0 is the vertex. And the axis of symmetry is this right here. X equals negative 8 is the axis of symmetry. So for number 7, you can see that we are shifted up or down. So we have a plus 4, which means we're going to be shifted up in the y direction 4 units. So we know that the y value will be 4. And the x value right here is negative 1, so that means we read it opposite. So that's 1, 4 is the vertex. And the axis of symmetry is right here. X equals 1 is the axis of symmetry. Go ahead and try number 8 on your own and see if you can figure out the vertex and the axis of symmetry. So I'm going to jump to number 9. I'll do number 10 since it's well, I'll do number 9 and then you guys can do number 10 since it is a little bit harder. So here we want to graph the vertex and we don't have a k value. So that means we're not going to be shifted up or down. That means our vertex will be on the x-axis. Okay, so we're not going to be shifted up or down, so that means our vertex stays on the x-axis, so it's going to stay along this axis right here. And we're going to shift to the left 2, because it's positive. So we're shift right there. Okay, now if you want to find the value of y when x is negative 1, we could plug that into the function. And also know that we're going to be facing upward because a is positive. So let's find out what the value of y is when x is negative 1. So m of negative 1 is equal to 3 times by negative 1 plus 2 squared. So that's equal to 3 times by 1 squared. So that's just going to be 3. 1, 2, 3, so right there. 1, 2, 3, and right there. So that's what our graph should look like. To help you get started on this one, first graph the vertex. So know that you're going to be up 4 on the y, and then your vertex is going to be to the right 6. So I'll give you that much, and hopefully you can find out the rest. So for exercise 11 and 12, what it wants you to do is to graph g of x. So that's this one right here. It gives you what f of x is equal to. So you see here f of x is equal to this function right here, but g of x tells you that g of x is the same thing as f of x, only you're shifting the function well, this is positive 2, so you're shifting the function to the left 2 units. So we want to take f of x and shift it to the left 2 units. Okay? So here's what we can do. If g of x is equal to f of x plus 2, what we can do is try and solve what that means. So g of x is equal to f of x plus 2. And we know f of x is equal to 3 times x plus 1 squared minus 1. So basically, f of x plus 2 means that instead of x, we're going to write x plus 2 where we see an x right here. So that means we'll write 3 times by x plus 2. So again, we're taking this spot right here and we're plugging in x plus 2 because of this right here. We're changing x to be x plus 2. So then we did x plus 2 plus 1 because of this right here. That's being squared minus 1. Now we can simplify this. So this is 3. So we have x plus 2 and then plus 1 right there. So that's going to be x plus 3 squared minus 1. So this is g of x. Remember, g of x was equal to f of x plus 2. And now it wants us to graph g of x. So we know g of x is now equal to 3 times x plus 3 squared minus 1. Okay? Remember how we said that g of x was f of x but shifted to the left 2 units? So you can see here that this is plus 3 and this is plus 2, or plus 1. So this graph right here is the same thing as this graph but shifted to the left 2 units, which is why we're no longer at 1, we're at 3. So then if I wanted to graph this, here's my y-axis right here. Here's my x-axis right here. So let's graph the vertex. So we're going to be down 1 on the y, and then to the left 3 units. So down 1, 1, 2, 3, left 3 units. Okay, and then if you want, you can create a table of x and y, or x and g of x. So we want to know what the values of y are to the right of this point. So that means you would plug in negative 2 if you wanted to find out what g of x is. And we're going to be open upward because g of x has a positive number right here. But I think I already know what it's going to be like, but if you plug it in, you should get negative 2, positive 2. And this is what your graph should look like. Okay, so I'll let you go ahead and do number 12. But basically what this one's telling you to do is g of x is the same thing as f of x, but you're multiplying it by a negative number. So that means you want to take f of x, you want to take this thing in its entirety and multiply it by a negative. So that means you're trying to do... Here, let me erase this right here. So g of x is equal to negative f of x, and f of x is equal to this right here. This is f of x. So if g of x is equal to negative f of x, that means g of x is equal to negative f of x is 1 over 2 times by x minus 3 squared minus 5. And then that means you have to distribute the negative inside. So g of x is equal to negative 1 over 2 x minus 3 squared. And then when you multiply it right here, it's going to be plus 5. Okay, so this is what g of x will look like. Now all you have to do is graph that up here. So I'll let you guys do that, but that should pretty much do it for this lesson for 3.4. And in the next lesson, we'll talk about 3.5. So let me know if you have any questions, email me, or I'll see you guys in class. Thanks.